Now, how do we implement this in PySpark? It is not too different than that of the batch processing. First of all, we'll have to create the Spark session. Then we'll have to create a data frame using read stream rather than the read API. So the API has changed here. Instead of read API, we are using read stream API. And the format can be either Kafka or Kinesis. I'll be using Kafka ingestion layer only. Then we mention multiple options. Because it is Kafka, we have to provide the bootstrap server also. I'll be using the local machine initially, then I'll show you how we can use it in MSK. But if you are using local machine, then it would be localhost colon 9092. If it is MSK, you'll have to copy the public endpoint or the private endpoint of the bootstrap servers and then paste it here, or put it in a variable and provide that variable here. We have to provide another option using subscribe, meaning that I'm saying that this Spark application will subscribe to the topic. Let's say the name of the topic is 3IAM stock topic, and then the load API. So these are the changes that you have to do when you are using the streaming application. Then we use or create another data frame wherein we'll be applying all the transformations. And once the transformations are done, we'll be using a separate API called write stream. Instead of the write API, we'll be using write stream API. And in format, you can mention Parquet, JDBC, console, Kafka, etc. So if you are using processing time trigger, or if you want to use frequent interval, then we'll have to mention this trigger option. If not, if you are not using any trigger as such, then we do not have to provide this option. And all the other options that you can provide, but we'll have to use this start API. If we do not use this start API, the application will not start. And a very important API is the await termination. We'll have to make sure we provide this API also, or else the streaming application will run just once and then stop. Nothing would happen. That's why you'll have to use this API, which is await termination, so that the stream application keeps on running till the time we terminate application by ourselves, either for an error or we manually stop that application. So let's do some hands-on, and it would be a very simple hands-on. Just to start the wheel rolling, we'll be creating a Kafka cluster on our laptop. I'll not be using MSK initially because MSK would cost a lot. That's why I'll be using Kafka cluster, or I'll be starting a Kafka cluster on laptop. Then I'll start a Spark standalone cluster, and I'll also start the Kafka cluster. Now there are certain considerations when we do coding using the streaming model. It is not like reading from CSV file, Parquet file, database files, etc., or databases, etc. The output would be very different. So by default, the output would look like the table that I have shown you here. There would be key, then there would be value, the name of the topic, the partition of the topic, then the offset, timestamp, and timestamp type. So we'll have to extract the value column from the output. Now this value is actually, the value should be in quotes like this. And this value column is nothing but this particular value column, because all the data would be residing in the value column. We can use df select value, or we can use df select call function followed by the cast method of the call function, which can be used to convert this value column. So first I will show you without using any trigger, and then I'll show you how to execute this in frequent time interval of 10 seconds using the processing time trigger. First, let's prepare the environment. This is the same sbin folder that we had used earlier in Spark session. And here we have the history server. We can start the history server. We can start the standalone cluster using multiple shell scripts. So first I'll start the history server, and then I'll start the master and the workers. Now let's look at the history server. It is up and running now. And let's look at the master server, which is also up and running. So I'll have to copy this to start the workers using the master, which is this one. And the configuration is same. I have not changed anything. It is the same Spark configuration that I had used in my standalone Spark mode, Now I should be able to see two workers running, and each one of them is using 5 cores and 5 GB of RAM. Now let's start the Kafka servers, or start the Kafka servers. This is the Kafka binary folder, and here I have Zookeeper. So I'll have to start Zookeeper first, and I have to provide the config, which I always forget for some reason. So the Zookeeper process has been started. Now it's time to start the Kafka server. Again, I'm on the same location, the Kafka extract folder, and then bin. And here we have this Kafka server start, and we'll have to provide the configuration folder or the configuration file, which is server.properties. It is in the previous folder, so I have gone back and then in the config directory and then server properties. So it should start the Kafka server. Now let's see whether we have any topic or not. I think I had created one topic. First, let me export the bootstrap server, which is localhost 9092, and then I'll be creating a Kafka topic. The replication factor is 1, and I'm using 6 partitions to create the topic. The name of the topic is 3am stock topic, and I got some error saying that okay, this topic already exists. Let me drop or delete this topic and create it again. So the topic got created, and as I said, this has 6 partitions. This particular topic, which is 3am stock topic, has 6 partitions. Now I'll be using the console producer to send some data, and I'll use the PySpark code to process this data. And before writing the PySpark code, let me start the console producer, which is this one. And this is the command: Kafka console producer bootstrap server topic 3IAM stock trading topic. Sorry, I have mentioned a wrong topic. So I'll be using this 3IAM stock topic to send some data here. Now let us go ahead and write the PySpark code. This is the code: intro Spark streaming. First, I'll have to import Spark session, and then I'll be creating a Spark session for that matter. Now I'll be using this to create a data frame, and instead of read API, I'll be using the read stream API, which is also listed here. So this is the API that is used to read the stream, which will be in Kafka. So that's why I'll have to provide the format, which would be Kafka. After this is done, we'll provide multiple options. The first option would be the Kafka brokers. Now here, I'll have to provide the bootstrap server or the Kafka bootstrap server. Using this configuration parameter, kafka.bootstrap.servers, and here I'll provide localhost 9092 because that is where Kafka is running. Now after that, we'll have to subscribe to the topic also, or subscribe to a topic, and in our case the name of the topic is 3IAM stock topic. Okay, so then finally we'll have to use the load API. Now this is the data frame which is used to create the streaming data frame, and whenever we start the application, it would be reading from Kafka bootstrap server, which is in local machine, and then from the topic 3IAM stock topic. Then you can use multiple APIs in between. Of course, I'll not do that, but instead of that, I'll be using the write stream API, and for that I'll have to use df1. Now instead of write, I'll be using write stream. This is the API which is also listed in the data frame. Then the format. Now where do I want to provide or put the output? For testing, let us use the console output. So the output would be in console, and that's what I'm mentioning in the format option or in the format method. Then we'll have to use the start API. I'm not using any trigger API because we'll do that later on. If you remember, I had told you that the final API that I have to use is the await termination. Let's execute this without that await termination, and let's see what happens. And we are getting this error: PySpark errors exception or fail to find data source Kafka. And the reason is because we have not provided any Kafka package, which is also needed. So to do that, we'll have to run this using Spark submit. But before that, let me use df2.await termination. Now, this is a very simple PySpark streaming code. It is reading from the 3am Kafka topic and then putting the output in console. That's all, as simple as that. Now, how do you execute this code? We'll have to use PySpark submit. So to do that, we'll have to execute this code in the terminal. Now, instead of using the black terminal, I'll be using the terminal here. First, let me go to the dataset 15 Spark streaming. So this is the output, or this is the code rather, and then I'll use Spark submit here. The output would be a little small. The screen is a little small. That's fine, but I do not want to use the black screen because I have kept that for the Spark and Kafka commands. So here I'll be using Spark submit. And after that, we'll have to mention this package dash packages org Apache Spark followed by Spark SQL Kafka. That's it. It is already available in the Spark binary. We do not have to download it separately, but this is something which is needed. Then, of course, the master. In our case, this is the master, and then the name of the code, which is intro to spark streaming.py. It will take some time for the package to get initialized. Now the code is running, actually the stream is running. So right now there is no data. As you can see, this is the output: key, value, topic, partition, offset, timestamp, and timestamp type. So there's no output here because there's no record in the topic. We have not put any record in the topic. So let's use the producer console, and till the time we send some data in the topic, it will keep on waiting because you have not mentioned any trigger time. So let's execute this without the trigger time and put some data there. This is the data that I'm sending. sprk123 may be the ticker ID and then the value. Now if I press enter, the Spark code should run and I should be able to see some value here. So this is the second batch. This is not the first batch. You can see this is batch number 1. In the earliest case, it was batch number 0. So this is batch number 0, and which did not have any value. But here we have batch number 1, which has some value, but you cannot see the value. It is not in string, so we'll have to convert it to string. The topic is 3am stock topic. The partition number is 2. The offset is 0. This is the timestamp, and this is the timestamp type. There is no key because you have not sent using any key in Kafka. So I will stop this application and use some of the APIs to extract the value here, because right now we are seeing only hex value. So let's change that. Okay, so I have stopped the application and I will use the data frame df2 to select only the value column. Let's say call value, and this is the column that we want, right? Of course, we'll have to import the column function, and now we have this df2 data frame. I cannot use the df2 data frame here anymore, and also here I cannot use df1 data frame because I want to see the value, right? So this is what I have changed the code to. Now let's execute this again in the command line. It is again starting, and now value is blank, which is batch 0, because we have not sent any data. So let's send the same data again, and now it would execute because there was some data, and this is the value. Again, it is in hex. We have got the column value, but the output does not make any sense. At least we cannot read the output, so we'll have to change it again. But we were able to extract only the value column. Now I'll stop this application again and let's change it or cast it to string and execute the code again. Okay, sorry, I am in a different directory, so I'll have to go to the actual directory and then execute this. Okay, so it is waiting for the input, but let's see, the value is blank in batch 0. Let's send the same value again. Now it would execute, and I have batch 1. Now I can see the value properly, which is Spark. The ticker ID is 123 and the value is 100. Let's send a different value. So this is the string that I'm sending, Kafka 1124 and 50. Let's press enter and immediately go here. It is executing now. I should be able to see Kafka 1124 and 50. Of course, it is not very user friendly, the output, and this is how we would get it in the console sync. We are not using any other sync. We are using console sync. But now what will I do is that I'll use the console sync itself, but instead of writing it directly, let's use the trigger API. And we'll have to use the trigger API after the format option. Remember that. And here I'll mention processing time, and let's say it is 10 seconds or maybe 15 seconds, and save it and then execute the command again. I'll have to go to the folder and then submit the code. Now the execution would happen after 10 seconds. Even though we send the data in the topic, it would not trigger the execution. The execution would only be triggered after 15 seconds. First, let me wait for 15 seconds and let's see a blank output. Okay, it got executed and you see the output should be blank. There is nothing which is batch 0. Now let us send some data, and I'll put multiple data in the topic. So these are the two values that I'm sending, or two records: AWS Cloud Data Engineering, GCP Cloud Data Engineering 2. Now it got executed after 15 seconds and I can see only AWS Cloud Data Engineering here. So it did not pick up the second value which got picked up now. So this is the second batch, right? So this is how the trigger processing time helps. And we can send multiple data points to the Kafka topic, but the execution would start only after 15 seconds. So this is how we can write a Spark streaming code, and we can put the output in console. And it is very helpful for debugging your streaming code. Of course, this is a very basic one. Let's do some advanced one wherein we'll use the JSON serializer and deserializer. We'll be using a producer code to send JSON data from a file to a Kafka topic, and then we'll use Spark stream processing to capture the data from that Kafka topic.